Good evening, everyone. Welcome to our first inaugural Caro Alumni lecture. My name is Andrei Kozlov. I'm a reader in the Department of Bioengineering and the Alumni Relations Officer. I have several things to say before the lecture starts. First, I want to thank Kemi and Robert for helping me to organize this lecture. Now, this lecture is dedicated to Professor Colin Caro, so I want to tell you a couple of words about him. Professor Caro was born in Durham, South Africa in 1925. He studied medicine at the University of Witwatersrand and graduated in 1961. And after that, he worked in several hospitals in New York, in the UK, in Pennsylvania. And then he came to London in 1960 and was appointed as a lecturer at St. Thomas Hospital. Professor Caro's research interests were groundbreaking and interdisciplinary. He carried out work in the fields of respiratory mechanics, atherosclerosis, and in general blood flow and vascular geometry. He also worked on new ways to image blood flow, and this led to the development of a small helical stent which was produced by a spin-out company, Biomedical. In 1966, Professor Caro co-founded and became director of the Physiological Flow Studies unit here at Imperial College. The unit became one of the first interdisciplinary biomechanics groups in the world. The group quickly earned an international reputation in the area of arterial and respiratory fluid mechanics, particularly for its pioneering work relating blood flow and vascular mass transport in atherosclerosis. In 1989, this unit went on to merge with the Engineering and Medicine Laboratory, which was founded as a research group in the Department of Electrical and Electronic Engineering at Imperial. And together, these two groups became the Center for Biological and Medical Systems, and subsequently became the Department of Bioengineering in 2001. Professor Caro remained an integral part of our department even after his retirement in 1991. He was appointed as emeritus professor, ran an active research group, and came to the department almost every day until the pandemic. So this lecture is named in memory of our dear colleague. And before I introduce the speaker, I want to read a message from Professor Caro's wife, Miss Marilyn Caro. I and the Caro family are very pleased to know that the Bioengineering Caro Alumni lecture to be delivered today by a Biomedical Engineering MNG graduate, Ingeborg Oie, will be celebrating the global impact of bioengineering and its contribution to the improvement of better healthcare worldwide. Colin's first degrees were in medicine, and he would be very happy and proud that the interdisciplinary research he and his colleagues were carrying out back in 1966 in the Physiological Flow Studies unit is still being passionately conducted nearly 60 years later and contributing to a better standard of life for all. We send everyone best wishes for a wonderful day and hope that this first lecture will be a precursor of many more successful events. Ms. Marilyn Caro. And now it's my pleasure to introduce today's speaker, Ingeborg Oie. She is the CFO of Agreena, a Danish climate tech company spearheading the world's largest soil carbon program. Ingeborg was part of the inaugural cohort of Biomedical Engineering undergrads at Imperial College London, graduating with an MNG in 2006. She also holds an MSc in Public Health from the London School of Hygiene and Tropical Medicine. Ingeborg's career began as a medical device analyst at Goldman Sachs and Jefferies, followed by leadership roles in various medical device and health tech companies. Her experience spans orthopedics, wound care, surgical robotics, digital technologies for remote patient monitoring and clinical trials, integrated health systems in emerging markets, power electronics for energy transition, and the application of simulation and AI in ultrasound imaging. Today, Ingeborg also advises multiple startup companies on strategy, fundraising, and scaling across both the healthcare and climate sectors. Ingeborg is a chartered financial analyst and a co-founder of ViaRace, a challenging 4,000 kilometers ultra cycling race across Europe. In her spare time, she is dedicated to transforming an old farm into a biodiversity heaven and occasionally cycles far. Please join me in welcoming Ingeborg today.
Thank you, and thank you for the lovely intro. Very, very honored to come back to the department and be invited to come back to speak. And I think I sort of, was preparing this, there's both a lot of memories from when I was a student here, but also a little bit of feeling intimidated, talking to so many people who've actually continued to do great science and very clever things. And I don't think there are too many of those references in my presentation because I haven't really done anything that's been rocket science since I left here. This is actually 20 years ago. That was the graduating, when the B-Eng class was graduating. I think what strikes me the most is the quality of digital photography back in those days wasn't so great, but we definitely thought it was fantastic that you could take a digital photo and pop it into a yearbook without having to go to some fancy press to get it printed. But this is actually what it then came out as. So this is the 34 students that were there at the time. A small cohort that came in, and you also have Professor Lever, who was the head of department at the time, and that I have to say, I think all of us remember as the sort of the caring grandfather that looked after us. The sort of the thinking about creating this lecture and talking about my journey, spending a lot of time in startup companies, I actually realized that the first experience that I had of startup companies was just probably being in the department, because this is what Professor Lever wrote in our yearbook. You have been the guinea pigs, the experimental material that we've been experimenting with, because the course was completely new, and I think a lot of things were made up a little bit along the way. And if we complained enough, then they might actually listen and think that actually here let's change this around a bit. And things did move really fast. You didn't necessarily have all the answers, but it's a good description of maybe what startup life is like. I will start with just telling you a little bit of the summary of what I've done, but most of the lecture is dedicated to startup companies and bringing technology into the market and the experience that I have had there. And I mean, you can read it on the page. Effectively, I did my biomedical engineering degree here. I was a student who didn't have much money at the time, so I had to go and make some money while I had summer holidays, and that's how I ended up working for investment banks, perhaps rather than doing anything in academia. So having discovered that, I went in to work for Goldman Sachs and then Jefferies. I still don't know exactly why they took me, because I spent time trying to prepare for that interview, thinking, I don't know what a bank really does, but I'm going to read the Financial Times from the beginning until the end, and then hopefully I'll understand a bit more and be up to date on current affairs. I don't think I was too up to date on everything, because the people in the trading department, they just sent me on to the research department, where there was a team that did medical device research, or research into companies that were doing making medical devices. And that team, I think, took a bit of pity on me not knowing anything about that, but they had a little project that summer about orthopedic implants, and thought I could actually do something useful there. And that is how it started for me, shifting into what was more the business side of medical devices rather than the science side. Working for a bank is often called the dark side, and maybe for good reason. I certainly, after a number of years there, felt that there had to be something a little bit more meaningful to do, and I started a MSc in public health, thinking that that's maybe a place to have an impact, and I also tried applying for jobs in developing countries, which I was not very successful at. And then, thankfully, someone who is here today, Phil, who sits over there, recruited me to work for Smith & Nephew and sort of rescued me out from this, this evil side of banking. And I joined Smith & Nephew doing investor relations there. So, many big companies, and then after that, I went into working for startups, which I'll talk more about. Oh, that's the clicker. Now, how did I go from these big companies into startups? This is me trying to count the days after I have cycled 4,000 kilometers across Europe and not having slept for 2 days. How did I find myself in that position? I think again I should probably thank Phil. Because at that point I had worked for Phil for 3 years, and that's probably the longest I have worked for anyone before and since. And I started to think that now I've done this for 3 years, what's sort of next? What am I going to learn next? And things do take time in large companies, and I guess I wasn't so patient. So I found somewhere else to learn something new, and I signed up for a cycling race, which was one of those challenges where you don't actually know if you're going to be able to finish it. So maybe that goes a little bit back to sort of research. When you start out on something, you don't necessarily know if it's going to lead you to something, but it's extra rewarding when it does. And I think I came out of that experience with a feeling that actually you can achieve more than you think, and it's time to give myself a little kick and try to actually go and do something different. This was the route that I followed when I did that journey on the bicycle, and I have never cycled as far as that in one go since either. But I do keep on cycling. Now I organize other people to do that kind of journey, so others can have, I guess, life-changing moments. So I was looking for something to do, maybe in a smaller company, and I started asking around. And this company in Cambridge turned out they were looking for a CFO, or a chief financial officer, and they were doing surgical robots. and they were looking for a CFO, not to do accounting and sort of look at budgets and put numbers into systems. They were thinking more about we need to raise more capital because doing robots can be quite expensive to develop. And so a big part of the role there was actually to raise capital. And working with investments and finance and business was what I had done. And that's where I think my first jump into the world of startups came from. Now, what's the definition of a startup? There isn't a perfect one, but maybe CMR was more of a scale-up at the time that I joined. Startups usually have a few people, an idea, have got it off the ground, maybe don't have much traction in the market, don't have a lot of sales, and then when you get to the scale-up, it's all about growing that product and bringing in more people, bringing in more funding, and making it be adopted globally. So it was probably somewhere right on the cusp of being more of a scale-up. It was about 50 people when I got to know them, and they had come up with this surgical robot in Cambridge and were preparing for that to get regulatory approval and then be brought into the market. I'll take a little sort of pause on sort of the startup, and before I go into more, but how do you find out if a startup is going to have any legs and get anywhere? This is what Sequoia Capital, one of the big venture capital firms in the world, tend to look at and recommend that you have a clear plan and that you include all of these things and then present it in a compelling way. So if I run CMR through this type of framework to give you an introduction to it, the purpose that the company had was to make minimal access surgery or keyhole surgery more accessible to anyone, anywhere in the world. The problem, minimal access surgery is quite hard to perform. Not every surgeon manages to reach proficiency, and therefore a lot of surgery was still being done as open surgery. The solution, according to CMR, was that if you could make it easier for surgeons to perform, make it easier to train, and make that affordable, you could bring it to more people. And so the solution was a surgical robot. Why was that the right time? Well, there had been a company around doing this. It's called Intuitive Surgical. And they had come out with a robot early 2000s. It had taken quite a long time for surgeons to maybe getting used to the idea that robots had a place in the operating theater, and a number of studies were starting to come out to say that the results were on par with good surgeons performing manual laparoscopy. So robotics was starting to gain traction, but it was only one company. And what CMR had was sort of a novel way of doing it. A key innovation that was patented, which was around the wrist of the robot. So traditional robots would typically hold an instrument like this. It means you need a big robot to get a range to move across the patient. And what CMR had was something that's maybe more mimicking the human way of doing it, a wrist that could do that movement and get the same reach. So there was a key innovation at the heart of it. The market potential was big. You could look at it in different ways. How many surgeries were there? Or you could just look at, there was one company having a robot. They were making $4 billion in sales. And they were only addressing maybe 2-3% of the market. Only 2 to 3% of surgeries that it could be used on, it was used on. So if you sort of do some generous maths, because I'm not into doing anything complicated tonight, 4 billion, if you say it was 5% penetration, the total market would be $80 billion. That sounds like something exciting to go after. And I think that's also what investors generally thought it was. I've already talked about the competition when it came to robotics, but actually what we saw as the real competition was surgeons doing it manually or as open surgery. That's what we wanted to be converting. Business model. It was also about innovating the business model, because one of the key disadvantages for robots is it's very expensive. It was very expensive in those days to buy a robot, and with one company on the market, there hadn't been much innovation around it. So it was also about making surgery almost like a service. You could have a subscription. This hospital is going to subscribe to 200 surgeries a year and then only pay for it when the surgeries happened. That was a key part of the innovation, to make it better for hospitals to be able to afford it. What was the team there? The team was actually a team of 5 founders. I was not one of them. I don't do I guess the big leap on the big idea of thinking of something. I generally come in and help people bring that forward and fund it. So it was a brilliant physicist. It was a gynecologist. It was a business person, and there were 2 engineers, one who was more project manager and another one who was sort of making the product engineerable. And financials, yes, they did have some very compelling financials, and they had managed to get some initial funding. And as things go in the beginning, I think you find things in random places. So one of the founders, he had a wife who took singing lessons, and the person who gave singing lessons was an author who had had some success and who provided the seed capital for the company. So if any of you out there are looking for money for your spin-outs, it does come from the strangest of places, or it can do at least, and it's not uncommon that the first bit of funding comes like that. And the vision was to transform surgery and to make sure that this was available to everyone. That's of course not exactly how it happened, and I think that's the other thing to take away. Things never go as you plan at startups and scale-ups. And on this one, I'll just talk a little bit about the competition and what I took away from that. So, doing all the good market research, we kept on hearing from surgeons and from hospitals that the company which is there today is not listening to their customers. It's too expensive. It's not flexible. It's a monopoly. They're not innovating. We need choice. Fantastic. This sounds like a market that is just ready for exactly what we have come up with, and they will just take the product and be so happy. As it happens, actually competition can change. You know, they also have their strategies, and in this case, I think Intuitive, the company that we were competing with, they adopted to this quite fast, and it turned out that, you know, as soon as we were in a hospital, they were also there, being much nicer than they had been before, and paid a lot more attention to the surgeons in that hospital. All of a sudden, they could also offer this subscription type of business model. You didn't have to spend $2 million in order for the robot to be sitting in a cupboard and not be used because it was, you know, too expensive to be used. The prices came down. It all changed, and they were actually very, very good at competing. So don't underestimate the competition when bringing something new in. I think the design is still winning on Vercius, the robot from CMR, and it is still a company doing well, but it wasn't as easy as we thought when we were launching this into the market in 2019. I mentioned that this required quite a lot of funding to do, building the robots, but building out an organization to go and sell it, train surgeons in many different countries. And the last thing I was involved with at CMR was a fundraise of about $600 million. So we did a Series D fundraising where investors put in $600 million into the company in order to be able to go into the US, go more into Europe, build a new factory. Effectively, did that and thought, now the company is set. There's only one way for me from here. That's probably downhill from there. So better go and do something else. So I left CMR and joined a company in digital health. I was really curious about software, but software business models, and technology had changed so many things at this stage. At this stage, it wasn't those grainy photos in a yearbook anymore. You would do your banking on your phone. You could buy insurance on your phone. All your travel is managed on the phone. But healthcare was still a place where you would typically have to go, and very little could be done on a phone. And that was the idea that the founder of Huma had. How can you make as much as possible of your healthcare fit onto a mobile phone and have that as your digital companion? I thought it was a really fascinating thing, an incredibly compelling story. And startups is often about storytelling. And that is what the company was particularly good at as well. And that maybe brings me to the next thing. If you are starting a company, and I know since I talked to a number of you on the showcase, a number of you are thinking of that, don't be scared of the competition because they have shiny presentations and have collaborations with just about anyone around the world. Because a lot of it is about how you present the facts that you have and the advantages that you have. Huma taught me a lot about that, because coming from maybe academia or coming from numbers is very tempting to focus on, what are the caveats? What was the actual detail of the study that said that it's actually not as simple as just putting one big number out there? But if you're going to sort of make it above the noise, you sometimes need to tell the story in the most compelling way and not get lost in the caveats. And I have to say, the founder I worked with at Huma was incredible at that. And you look at this page, it sort of collaborates with all the leading companies in the world, got some fantastic statistics. Doesn't mean that all of those are the current collaborations. It could be things that have been done in the past. And which number is it here? Maybe the 3,000 plus hospitals and clinics. That's GP clinics that are most of those. Of course, they are also clinics, but when you see it, you think, oh, maybe that's 3,000 hospitals. There's nothing wrong with the numbers that are there, but it's like, how do you present them in the best possible way so that you get the attention? And Huma was exceptionally good at that, because the founder ended up actually knowing the CEOs of most of those pharma companies because of the storytelling that came with it. So don't forget about the storytelling. It is incredibly powerful as a tool for being able to get your business to where you want it to go, and to convince investors to give you money, which is what I spend a lot of my time on at companies. Now, digital health and changing the health system actually is really hard and slow, and much slower than banking. If you talk to people in banks, they say we're so regulated, everything moves so slowly, but actually they just haven't seen healthcare. So after a few years and feeling like this was actually quite slow, I lost a little bit faith in that this would move very fast. And there are other big things impacting people's health. And I decided to go into something which is more around the environment and another really big problem to work on. I think that's what I seem to be attracted to, big problems and big ideas and ambitious companies. So I hadn't thought much about farming at that stage, but it was really a lot of interesting things that I learned as I started looking into what to do in the more environment area. And to learn, and this is actually the only quote from a paper that I put in. I thought I should have one quote since I was actually at Imperial. That we've produced lots more food since the 1940s, but the nutritional value or the level of malnutrition has actually not gone down. So we're producing more food with less nutritional value in it. That is not great for health, and also the way we're doing it is deteriorating the environment. What's the alternative, and what does Agreena do? Agreena is helping farmers do more regenerative agriculture, so a less intensive way of farming, and a way of farming that is focused on capturing more organic carbon in the soil. So that's got two benefits. I mean, the one that I thought of first on the health side, but more so when it comes to the climate, that you can actually use our soils as carbon sinks. Plants grow, they capture carbon, goes into the roots, and if you don't disturb that soil, it can actually stay there and be a place that stores carbon. And if we could make more and more farms transition from doing it the conventional way to regenerative, you actually have a climate solution that can work a lot faster than many of the high-tech solutions that you may also hear about, sucking carbon out of the air and storing it under the sea. That is not technology that's at a very scalable level, but farming could be. So what Agreena as a technology company does is help farmers measure what they're doing. So you can calculate how much carbon is stored in the soil. With that, you could issue carbon credits and get paid for it. Because the key is here, when it comes to the sort of the business model, is that for farmers, it's difficult to make this change. Even if it sounds great, they'll produce better food, and after 5 years, they'll even have more profits. But the in-between period is really difficult. And that is what we try to help with by funneling financing to farmers in that period, by helping them measure and get sort of certification that the amount of CO2 that they have captured actually is the right amount and can be measured and sold to people who want to do offsetting or want to lower the emissions in their supply chain. So the business model there was also a very important part of what we came up with. Getting farmers to change is actually almost as difficult as changing healthcare systems. Farmers tend to do things the way they have done. It is very community-based. So again, the storytelling here comes back for actually the business. How do we tell the story from farmer to farmer that there are other ways of doing it and that you can do that successfully? So this is something that we're doing in 20 countries today. The company has got about 150 people working there, and we've raised roughly 80 million euros to be doing that. If we want to go globally and take over all the farmland in the world, of course, there's more money needed, and I think that's always the case, and the choices to make as sort of founders and companies. Do you try to do things really fast and get investors to come in and fund the fast growth, or do you take it a little bit more slowly, less reliant on external investors that want to see growth? And finding that balance, I think it depends on what sort of company and idea it is. But I seem to always go to the companies that work on really big things, that need a lot of money, and where it is definitely not a given that that's going to be successful. But it always looks really successful on the PowerPoint slide and on the internet. So just be aware of that. Every time you look up these extremely successful companies, underneath, I guess every family is unhappy in its own way. That's how big the ambition is that we're working on. That the impact is visible from the moon. And you may think that brown fields is a farmer that's looking after it really well. You know, they've been out there and looking after their fields. But actually, we should never have brown fields. We should have green fields. That means that they're always covered. There's always something growing there, storing the carbon, restoring the health in the soil. And that's what we hope to be able to see from the moon one day, a greener planet. Now, I've talked to you about the 3 companies I've spent the most time on, startups that I've spent the most time on. Question that I asked myself at the end is, what is the most successful one? And I guess, how do you measure it? If we look at growth, ability to attract funding and grow out, I reached a slightly unexpected conclusion. So I think here maybe a little anecdote. When I first walked into this office, it was in a basement, and I tried to find some photos, but there weren't really any photos of it. But there is a video of the time of moving into that office, and there was a few musicians playing and having a little, and the musicians were sort of hiding under the staircase, playing, because it was the only space where there was space for it. There had been a little bit of funding come in to be able to get that space off the ground, but now that startup has attracted way more funding and is operating out of these buildings. And I really wish I had a photo from the Bagrit Center as it was when I joined Imperial in 2002. But it just doesn't seem to exist on the internet. As I said, it's the YouTube video from 1991 when it was inaugurated. Was the only thing I could find. You can go and look it up, but there was like 3 people playing instruments under the staircase in this little basement space that we had when I joined. And look at what the department is now, thanks to very successful growth. These are the growth metrics of the department. So that's 5 times increase in academic staff a 20-time increase in undergraduates since I started. And those of you who know something about finance will also see that that's incredible operating leverage to only have to increase staff numbers by 5 times and to go 20 times on the number of students that are being taught. So that's some pretty impressive metrics in that 20-year period. Now, I think the department, I'll finish on a little bit of a personal anecdote. The department has always also been doing some ambitious and at the forefront of things research. And when I was in my final year, I had a final year project that I needed to do, and Professor Etienne Baudet had just joined the department. He was working on brain-machine interfaces. And I thought this sounded quite interesting. You may see a connection to robotics, but he sent me a message when I asked about a project. He said it would be possible to work on our micro-assembly training system project. We now have a lot of software, and it is time to perform psychophysical experiments. Fantastic, I thought. But I actually don't think I was particularly good at it. So this project turned into, from being psychophysical experiments, into being actually a literature review. I didn't have fancy AI to do imaging back in those days. So I got my sister to draw the illustrations of these robotically controlled mice. That was the subject of this literature review. That was in 2006. Now, in 2016, a company called Neuralink was started. So just imagine if I had actually stuck to this and been a little bit better at the academic stuff. Brain-machine interface is now something that Elon Musk is spending some of his time on. But I guess I wasn't too good at it, but at least I kept the illustrations. So that is the end of the lecture. I hope you've taken away a few things about startups and maybe more the business side of what technology innovation is and can do, and finishing up with maybe Professor Colin Caro. When I joined the department, he was of course coming into the office, and as someone having just turned 20 thereabouts, sort of in equal measure, you were wondering and marveling at this person. He had retired more than 10 years prior, and he was still coming to his office every day of the week to do research. And I think that says something about the passion that he had for that. And having found my way into companies that do ambitious things, I think I'm starting, as I'm getting older, to understand why retirement is not the most exciting thing, but to be able to work on things that you enjoy so much that you can actually think about continuing to come to the office every day for the rest of your life is that. And so I guess I have somehow found a way to do something that I like, and maybe Colin Caro provided some inspiration for that. So thank you, everyone. Another grainy photo of all the people who were there back in those days that I should thank for the influence that you've had and for inviting me back. This department has great tenure, because many of those faces, those of you who are here, will possibly recognize if you can look beyond the slightly poor quality of the print there. So thank you, everyone. Happy to take any questions that you have, and yeah.
One, two. Oh,
I think we got the question.
Hi, really nice talk, thank you, and amazing biography. On crop rotation, so you're growing green every year, but traditionally we rotate the crop and then leave it fallow. How do you do that? How do you maintain the health of the soil?
Crop rotation is definitely part of it. It is not something that contributes particularly to the carbon capture, so it's not one of the sort of key practices that gets farmers paid in the Agreena model, but it's a key part of making the fields be healthy and not having disease. Leaving it fallow, typically you can plant cover crops, so to make sure that there is something growing, but that it is something different, and that's what you would encourage to do, both in the winter as well as part of crop rotation.
Okay, thank you.
Do we have any other questions?
Hi, thank you for sharing your experience with us. It was really inspiring. So my question is that you said you're attracted to big problems. So what's your thinking or experience of trying to work with policymakers and trying to convince them that this is a big problem? Let's try and work on this together and maybe attract some public funding, for example.
It's a great question and a big problem as well. And I think, when I studied public health, one of the reasons I didn't stay in it was that policy really takes a long time. You can have a big impact with changing policies, but it's difficult. You could work on something for 10 years and it may not come to something. So it's not easy. I think having that as the only strategy is not a very good strategy, but having it as part of the strategy, most companies would do, and trying to find models where it's not reliant on needing that, but that it would be helpful, is more viable than relying on it, because it is definitely potentially erratic, and there have been a number of examples of, say, reimbursement changes completely changing an industry or a product. But how to work with it and how to make someone see that it is a big problem. Connections, find people to talk to, find the right avenues as you get to a bigger stage. Typically, companies employ people who only focus on that, and if it's a key thing in the company, in the robotics company and also in Agreena, we do have in-house people who are focused on staying on top of policy, spending time in Brussels in order to try to understand what are the changes coming and how can we make the case why they should think about seeing the problem in our way. But I think it is about how can you create a coalition of as many voices as possible, because if you're only one voice, the policy definitely doesn't change.
Do we have any other questions? Hi, thank you for your presentation. I have two questions. I was really intrigued by the fact that you finance farmers in the years of transition to the Agreena solution. And I was more curious about your business model in that regard. Like, how do you stay on top of your funds if you're financing these farmers? And my second question is, how did your cycle trip change your life, and what did you take away from that? Thank you.
Yeah. Thank you for also asking about the cycling and not only the business. On the financing, it is actually quite a tricky thing to try to bring financing forward for farmers, and we haven't worked out how to do that fully. The ideal thing would be to say, we know that there are going to be these climate outcomes over the next 10 years, and we're going to take the sort of the value of that and bring it to the farmer at the very beginning, so they can use that for buying new equipment, the investment up front, the uncertainty. But that is unfortunately not very viable as a business model. So we're today just somewhere in between. The farmers get started with the promise that they get paid once the first harvest of greener or regenerative crops are made and the carbon credits are issued. So we're not able to do that fully, but we're working on getting partnerships with banks. So if we can demonstrate to the banks and prove that this is greener lending, maybe they'll give some more advantageous interest rates on loans to farmers. So that's one route that we're working on, and have some pilots on that in Moldova and in Ukraine. The other thing is to see if you can find someone who is willing to, who's got sort of different pools of capital and who are patient and willing to sort of look at that longer term and bring some of that forward. That is typically not venture capital investors and funds like that, although maybe for shorter periods you can convince them that it's the right thing to do if that can be really accelerating the growth. But it's not easy to do, but I think what we're doing is better than there not being anything there. And then the cycling, what did I take away from it? I guess I like spending some time by myself. I'm actually quite okay with spending time with myself. And I think the thing that I said was what got me going is that what got me going on shifting into working for startups was a bit of a boost to the confidence that I actually managed to reach the end when most of my friends thought that wouldn't actually be the case. 50% of the people who started didn't make it to the end, and I even finished as the second woman. So I guess I realized that I was capable of more than I thought, and where I am often prone to a little bit of imposter syndrome when I do something that I haven't done many times before. It helps. Those sorts of things help to actually show that, well, you can jump into it and take a chance and come out, and it's okay, even if everyone around you look like they're super experienced. All these guys talk to me about, the tire width and exactly what gear ratios I should be having, and I frankly didn't understand what they were talking about. So I was a bit terrified when I started out on the journey, but a lot of them didn't actually finish, so it's not always about those sorts of technical knowledge. Sometimes you just have to have the grit and the determination to go and do something.
Are there any other questions?
Hi, thank you for your presentation. I want to know what factors do you take into consideration when you choose to work for a startup? Because your job is CFO. For a startup, the financing is very important. Yeah, that's my question.
I think it's not maybe a job that's suitable if uncertainty and not knowing what's going to happen for the next 2 to 3 years is something that scares you. Because as I think I said on a number of these things definitely didn't go exactly to plan, and having to be part of actually cutting back and reducing the number of people, and sometimes reducing your own role is things that I have also had to do. But you do get to work on really exciting things. You get responsibility that you perhaps wouldn't get at much bigger companies. You can work on many different things. You don't have to be a specialist in just one area. And if it is successful, you can look back and see that it's had an impact So yeah, definitely, I don't think it's for everyone. It's not the place that gives the greatest job security. There are many other careers to choose if job security is important. But I think it's a very exciting thing, and to be able to work on lots of different things and solving problems.
Could I please take the liberty of asking the final question?
Yeah.
So something that you mentioned just as we were meeting today is just you reminisced a lot about your time in bioengineering, and it's clearly very special to you. So I just want to ask, what do you think it is about this department that has been so special and makes it such a place that you'd want to come back to and be connected to?
That is a very good question, and it's a very different department today compared to when I was here. What got me in the first place is if you innovate, come up with new ideas or solve something in that intersection between medicine and technology, you can make a real difference. And bringing together people from very different backgrounds in to try to solve those problems is something I think the department really is doing. And now there are so many different specialisms in here, much more than when I was here. But I think the special thing is to bring all of that together and to create an environment where now, I mean, when I was here, there was no such thing as a startup. I think startup, people hadn't even heard of it. It wasn't on anyone's radar. It was definitely not a career choice one could think of making. But look at all the spin-outs that are coming out, all the interesting ideas that are being generated. And I think that is the thing about the department, putting all of those things together, people from different disciplines, to solve things that are definitely worthwhile solving.
Thank you so much. Ready, Dan? I'm now going to hand over to Professor Danny O'Hare to give the vote of thanks.
Thanks, Kemi. Thank you, Kemi. And thank you so much for coming back, and what an absolute joy to see you again, and your inspiring tour de force today. Well, you can see the attention that you've been able to get. Those of you who didn't catch that, my name's Professor Danny O'Hare. I'm a Professor of Biosensor Technology in the department. I've been here since very nearly the beginning, just shortly after that. And Ingeborg's memory of being taught by me was that I spoke too fast and made jokes that were incomprehensible. So you've been warned, and if I'm keeping you from your drink, now's a good time to get out. But it's often been said, I think, that behind every successful child there are two puzzled and surprised parents. And I suppose there is a similar situation with academia and its alumni in many cases. But I think it's fair to say those of us who remember recruiting and teaching Ingeborg have not been at all surprised by your hugely successful and worthwhile career to date. Before I get stuck into some of the, I'm going to keep the more juicy details for more informal conversations later, but I need to say a few words about Professor Colin Caro, whose generous bequest has made tonight's lecture possible. He was one of the founding fathers, as we've heard, with James Lighthill, of the application of engineering and physical sciences to biomedicine and clinical practice, and worked into college well into his 90s, including consulting and spin-out activities. So in his early 90s, it was when Varian Medical began manufacturing and getting clinical approval for his helical stent, which arose really from his lifelong commitment to the fluid mechanics of blood flow. Those of you who are interested in that should know that the Mechanics of Circulation book, which he co-authored with Tim Pedley, Bob Schroeter, and Tony Seed, is still in print and still inspiring bioengineers to this day. In a slightly more flippant reminiscence of him, I ran into him in the lifter when he must have been about 92. I was trying to work this out. And he had this mortified look on his face, which I asked him how he was doing, and he said, those people at the American Physiological Society had asked him to write a reflection of his life in medicine and physiology, and he was absolutely livid, mortified at the thought that he was actually at the end of his career. at a mere 92, the horror. So I suggested that he did go ahead and accepted their offer, but that he should call it Colin Caro, the early years. Bioengineers can have very long careers, and I think you should bear that in mind, as indeed many of the students here should. So it was in 2002, under the leadership of the late Professor John Lever, whom we've heard such kind words about, that we began our integrated undergraduate master's program, and we were very much a skeleton crew of around 10 full-time academics and 0.5 FTE administrative staff. I mean, there are still some old lags kicking around the place. Professor Kitney, Professor Barath, Professor Bull, Drakakis, Weinberger, myself, still in the department. And Baraona, who I believe was your personal tutor, is still in college, but now in the Department of Mathematics. And in addition to his research in graph theory and network dynamics, at the time, because we were so pressed for administrative support, he was also responsible for managing the financial budget of the department. So, and Kim Parker is still around and still active, still working on wave propagation and other abstruse mathematical engineering concepts. But you recall, I think, some very dubious nutritional advice he gave you. He say, what is wrong with a diet largely comprised of custard and fruit? But anyway, the department now is more than 55 academic staff FTE, and we this year we admitted 135 biomedical engineering MEng, 64 molecular bioengineering, which I still think of as the new degree, but we also admitted 27 to the BSc Biomedical Technology Ventures, which is the actual new degree, which I think is now 2 or 3 years old. We have new labs, microfabrication facilities in the Michael Uren building, whole White City campus presence, God knows how many floors of lecture theatres in the Royal School of Mines, 4 floors of labs in the Bessemer building, and it's all rather a far cry, I would say, from the rather primitive facilities that you first encountered as our first cohort of bioengineers. We were hidden then to a large extent in the Leon Bagrit Center in the basement in the mechanical engineering, which Ingeborg remembers as a rather ugly 1960s style building with big machines in it looking like a factory. As though there's a problem with something looking like a factory in a college like Imperial. I don't see a problem. But there was, however, a very good esprit de corps and regular social events, including the International Food Night, which was shared with the MSc students. And Ingeborg, before her later obsession with cycling, was also the captain of the bioengineering football team. So there are literally no limits to your talents as far as we can see. So it was into this ill-formed maelstrom, to use an appropriately Norwegian reference, that we were fortunate to recruit our first 39 undergraduates, including Ingeborg. And the first recruits were absolutely brave pioneers. We'd either not quite or we'd just achieved our first professional accreditation from the Institute of Mechanical Engineering, shortly followed by IET, IPEM, and the Institute of Materials. And the subject was barely extant in the United Kingdom, certainly not as a proper undergraduate subject, and there were no major employers for biomedical engineering graduates. So those lucky 39 were either reckless or plucky or both. And I think you're a good example of all of those characteristics. So in early 2002, Professor Bull, Anthony Bull, and I interviewed Ingeborg for her place in the first cohort. She was just completing her secondary education in France at the time. And this really impressed me because I thought here she was being interviewed for a brand new engineering degree in her, what was possibly her third language at that stage. So we have disparate memories, it's fair to say, of what the interview questions were. But I do remember the interview, and I recall being hugely impressed. And I remember thinking, how do we persuade her to come? And I know I definitely said that to Anthony afterwards, and I may have even said that out loud during the interview. So Ingeborg's love of numbers and keen and enthusiastic intellectual interest in almost everything from an early age, all of that came out during the interview. And in those days, we were still allowed to see the other courses that applicants had applied for. And we were both amazed and surprised to see that she'd also applied to read civil engineering and mechanical engineering, also at Imperial, but that biomedical engineering was her first choice, as it indeed should be. She was clearly determined to study at Imperial College and determined to be a pioneering undergraduate in biomedical engineering, and found the perfect fit, I would say, in bioengineering, even if most people at the time had not heard of the subject, because it combined her interest in medicine with her faculty and facility in mathematics. So after successful graduation, we've heard the career plan, and I think hugely successful trajectory, and I hope it's an inspiration to the younger members here today. And her latest move to orientating towards environmental matters takes her back, I think, to her farming roots in the middle of nowhere in Norway, and working on how to decarbonize agriculture, using her expertise in both technology and in finance. So a real engineer, and a real credit to the Department of Bioengineering. And I'm sure we'll all like to show your appreciation of Ingeborg's terrific educational and illuminating inaugural Caro lecture. So thank you.
Just a quick reminder, there will be a reception with alcohol. Yeah, I was thinking, anyway, in the same place where the show was, on Exhibition Road in the entrance, so don't miss it. Yes. Oh, sorry. Don't go to drink alcohol just yet. Please wait a second.
On behalf of the Bioengineering Department, a small gift to say thank you so much for being our first Caro Alumni lecture speaker. Thank you so much for being such an engaging speaker.
Thank you. Thank you so much. Thank you. Wow.
Thank you so much. Oh, that was such a great talk. I don't think you realized how